So in Python, equality operator and identity operator, one is equal and the other one is operators are often confused, but they actually serve different purposes. So here's an example. Let's say A is 5, B is B, make it 257, and Y also 257. X is Y, and you get a false. So to dive a little deeper, in Python, integers are cached, so meaning that there is a set of integers from -5 to 256 that are pre-allocated in memory. So when you assign a value to a variable that falls within that range, the range is -5 to 256. So when you are out of that range, it will return false. It will create a new memory if it's out of that range. In one, -3, and 2, -3, and 1 is, and 2, you get a true. Well, it's also applied to, let's say this time, L1, we give it 1, 2, 3, and L2 also 1, 2, 3. So for L1 equal L2, we get a true, and for L1 is L2, we get false, because they are different objects in memory. We do string 1, hello, and string 2, also hello, string 1 equal to string 2, you get a true. String 1 is string 2, we also get a true, due to Python's string interning optimization for short strings. We're going to define init object. It's just defining a custom object. We get false for both cases because they're different objects in memory. However, if we define equal here, now we get the true because the values are equal, and here we get the false because they are different objects in memory. So let's do this. Y x none, y none, and x equal to y. X is y. So in this case, we get true on both. None is a singleton, so there is only one instance in the memory. We're gonna instance none, and then define new. It's none. So we got a true because they refer to the same instance. Another example using in an instance, specific instances. Example 3. We'll define animal class. Using is for identity checks. Essentially understand the context and be mindful of potential issues when dealing with mutable objects. And use the is when checking singletons like none, or when working with objects designed to be a single instances.